So this is the Chapter 3 review. We're going to work our way through this. The majority of the chapter was about solving systems of equations. And a system of equations solution is where two equations cross, or another way to state it is the x and the y value that works in both equations. There's different possibilities. You could have two equations that are inconsistent, and that simply means that they're parallel lines and they never cross. So that would be an inconsistent system of equations. They have absolutely no points in common. Then you could have a consistent and dependent system of equations. And that means that they have, if you will, infinitely many solutions, or they would graph the exact same line. So you would get that line, and then you would turn around, and when you graph the second equation, you would graph right on top of it. Okay, and you should be able to tell by their equations that they graph the same line. That is considered consistent and dependent. You also have a third possibility, which is where we did most of our work at, where you have consistent and independent. That means that you have two lines that cross at one location, so they have one point in common. That x and y right there is the point they have in common, and that's what you would, if you graphed it, you could solve it that way. Or if you put it in, you did elimination or substitution, you're finding the x and the y that actually work in both equations. So let's work on some of these. We learned that we could solve them by graphing. We could solve them algebraically by either substitution or elimination, or we could solve them by Cramer's rule. Those are all the different ways that you need to be able to solve a system of equations. So let's do a little practicing here. We're going to take the same equation and we're going to solve it all of those ways. So the first way is going to be graphing, and in order for you to solve by graphing, you would have to rearrange the equation. So this becomes y is equal to negative 2x plus 4. And this one would be, if you rearrange it, it's going to be y is equal to x minus 2 once you rearrange it. So to graph, you're going to go up 4. 1, 2, 3, 4. And then you're going to go down 2 and over to the right 1. And that's going to graph, and I don't have a ruler here, but it's going to graph that line. And then down here, you're going to go down 2. And then you're going to go up 1 and over 1. And it's going to graph that line. Now, I am guessing that the point that they have in common is 2, 0. But you know that you can plug that into your calculator under y equals, and then you can find the point of intersection. Okay, I'm going to try and straighten this up a little bit. So that's solving by graphing. Okay, you always want to use the calculator as a backup to find the point of intersection. Same equation, solving by substitution. You'll have to pick one of the equations to solve for either the x or the y, and you always want to pick a variable that you have an understood 1 in front of. So I'm just going to take this one, and I'm going to solve for the y, and that is going to become my key. I'm going to take that equation and plug it back in to the other one. Now, if you don't plug it back into the other equation, it will be a cycle motion, and you'll keep getting infinitely many, which is not the right answer. So where the y is down here, I'm going to plug that in. So I have x minus, and then the whole thing is 2x plus 4, because that's what y is equal to, equals 2. So I have to distribute the negative on this. So I have x plus 2x minus 4 equals 2. So when I put those together, I have 3x. When I add 4 to the other side, I have 6. Once I divide, I find out that x is equal to 2. Well, of course, that was the same solution that we got with graphing it. To find the y, I'm going to take that x and plug it back in. And so I've got y is equal to negative 2 times 2 plus 4, which is going to give me y equals 0. So again, the point of intersection is at 2, 0. So I've gotten the same answer when I solved it by graphing, when I solved it by substitution. Now let's do it by elimination. Elimination, you actually are making these two equations in such a way that you either eliminate out the x or the y. Right now this is set up to eliminate out the y. So I'm just going to add these together. And of course I have a positive y and a negative y, so they eliminate out. 2x plus x is going to give you a 3x. 4 plus 2 is going to give you a 6. And when you divide, you're going to get a 2. You'll have to plug that 2 back into one of these equations. Let's do the top one. So 2 times 2 plus y equals 4. So I have 4 plus y equals 4. I'm going to subtract 4 from both sides, and I'm going to get y equals 0. So the point they intersect at, or the x and the y that they have in common, is 2, 0 by the method of elimination. Same answer that you got with graphing and substitution. Okay, the next way that we learned, and the final way, was by using Cramer's rule. Now, to remember how to do this, you have to go back and remember what a determinant is. If I have two parallel lines and I have a square matrix, so let's say I have this matrix. To find the determinant, you multiply up, so that's going to give me a negative 2. Multiply up, that's going to give me a 12, and then I'm going to subtract. So the determinant is negative 14. It's a singular number, not necessarily one digit, but a singular number that represents the array of numbers that we call a matrix. So first thing we have to do here is we have to put it in a matrix form that's going to give me the x and the y. So that requires me to remember the positioning. So remember, on the bottom I'm going to do first and middle. So I'm going to do a 2 and a 1 because I'm grabbing all the coefficients, a 1 and a negative 1, and that's going to go on the bottom there, and that's going to go on the bottom here. Then I'm going to pop on over to North Africa, and I'm going to go and read backwards, and I'm going to go last and then middle. So I have a 4, a 2, a 1, a negative 1. Then on the y, I'm going to do first and last. So I do 2 and 1, 4 and 2. Okay, so I find the determinant, I multiply up, that's going to give me a negative 2. Multiply up, that's going to give me a 1. When I subtract, I'm going to get a negative 3 on the bottom. So that's what I'm going to put on both sides. Multiply up, negative 4. Multiply up 2, so that's going to give me a negative 6. So when I solve that, I find that x is equal to 2. Not a big surprise. We already know that by graphing, substitution, and elimination. This is a 4, and this is a 4, so I have 4 minus 4, which is 0. Remember, if 0 is on the top, then your answer is 0. So y is equal to 0. So same answer, but I did it 4 different ways. And so you need to make sure you know how to do it all 4 of those ways. All right, then we moved on to graphing inequalities. This was not difficult. If you know how to graph on a coordinate plane, you can do this. You just have to remember to shade. Negative 2 is my y-intercept on that first one. And I'm going to go down 1 and over to the right 1, but you'll notice there's not a line underneath it. So this is a dotted line that goes through there. And then I'm going to have to graph the other one because I'm looking for the area they have in common. So this would be shading above it. I'm not going to shade it until I get the other one on there. So the other one, I'm going to go up 2. And then I'm going to go up 1, 2, 3, and over to the right 1. And again, this is a dotted line because there's no line underneath it. And it's less than the line, so I'm going to shade this way. So the area that they have in common is all of this space right here. So you've got to be able to do that. And then we turned around and we put this where we have bounded regions, but we're going to try another one first, so you might want to pause the video and come back. If I have x is greater than -1, here's my -1. And perhaps this would be a good time to get into the habit of putting your equation in there. Okay. Whoops, I wrote y, but it's x. Okay, x is a vertical line. So if it's greater, it's to the right. Then I have this one, which I have 2. And then I'm going to go up 2 and to the right, 1, 2, 3. Again, this is a dotted line. And I'm going to shade below the line, so now I'm down here. So this one I have to solve for. So I have y is greater than or equal to 4 over 3x. And I could put plus 0 if I want right there. So here's my y-intercept. And I'm going to go up 4, 1, 2, 3, 4, and over to the right 3. Which is going to be right there. 1, 2, 3. Okay, so this is going to be a solid line through that. So the area they have in common is this little triangle right here. Okay. All right, then you did a thing on linear programming. Linear programming, you have to do what we just did on the graph, but then you have to find the points of intersection that you can plug back in. So we're going to go ahead and get these on our graph. We say y, which is a horizontal line, is greater than 2. So this is a dotted line through 2. And I'm going to shade above this line. And then I have a x that is greater than 1 and less than 5. So those are 2 lines right here, 2 vertical lines. This is x is 1, and this would be x is 5. And so it's greater, so right now I'm in this area right here, okay? So then I have to graph the last one, and I'm going to go up 3, and then I'm going to go up 1 and over to the right 1. So that is going to graph that. It's less than that line, so I'm looking for this space right here. Okay, now that tells me that there's going to be an ordered pair here, an ordered pair here, an ordered pair where those two cross, and an ordered pair here. So some of those I can already tell you what they are. So this one, by looking at my graph, it's a 1, 2. This one, by looking at my graph, is a 5, 5. Now, I didn't write the equation there. That green is y is equal to x plus 3. Okay, so this point up here is the intersection between these two, and I can do substitution, and I can find that this point up here is the point 5, 8, because that's what I get when I substitute the 5 in. Okay, so there's 3 points, and this right here, I am betting, in fact, I know it is, I can look at where it crosses, and it's the point 1, 4, okay? Actually, it's the point 1, 5, I'm sorry. 1, 5 would be this point right here. 1 and then 5, okay? No, that's a 4. That is where it crosses at 4. So it's the point 1, 4. It's kind of hard on this to see what line was where. So that's the point 1, 4. So then I turn around and I put all of these back in, and this video might stop and I might have to pick back up. This is my x and my y, and this is the equation that I'm going to plug it into. And this is going to be the answer that I get from that equation. So I'm plugging in 1, 4. I'm plugging in 1, 2. I'm plugging in 5, 5. And I'm plugging in 5, 8. And I'm plugging them into that equation, that constraining equation. And that's going to give me 3 minus 8, which is going to be a negative 5. This is going to give me a 3 minus 4, which is a negative 1. This would be a 15 minus 10, which would be a 5. This would be a 15 minus 16, which will give me a negative 1 as well. So what I find is this is my minimum point, and this is my maximum point. Okay. All right, so that's linear programming. You've got to be able to do that. The last thing that we did in the chapter was solving a system of 3 variables. This is quite extensive. You want to make sure that you don't make any mistakes. And so remember, on this you're doing like a combination of elimination and substitution. So we'll take these first 2 equations. I'm going to go ahead and move them over here. And I want to choose what I'm going to eliminate out, either the x or the y. And I think I'm going to go ahead and eliminate out, I don't know. Let's do the x. And I'm going to multiply this by a negative 2. Okay, because I want to have a positive 4 and a negative 4 so they go away. But I have to remember that I have to eliminate all of it. So I'm going to move this equation over. Make sure you keep it very organized. And double check for careless mistakes, because it's the careless mistakes that are going to make this problem go on and on forever. You have to multiply everything by your negative 2, including your 45. Okay, then I'm going to add that. Now, if I've done it right, either my x or my y will eliminate out. So this is going to give me a negative 5 plus a negative 4z. Is equal to, and that's going to give me a negative 56. Okay, and I'm going to circle that because that's an equation that I'm going to come back to. Then I'm going to take 2 others equation. It doesn't matter whether it's the middle and the bottom or the first and the bottom, but you do have to still eliminate out the same variable. So I have to eliminate out the x, so I can put the answer to my next equation with that one. So let's do the second and the third, and I'm going to actually multiply the second. Okay, let's pull it down here real quick. And I'm going to multiply this top one by a negative 3, and I'll multiply the bottom one by 2 so that I can have a negative 6 and a positive 6. So this is going to give me a negative 6x plus a negative 12y plus a negative 9z equals a negative 145. Okay, and then I'm going to do 6x plus 4y plus 8z equals 94. And then I'm going to add those together. And when I add those together, the x eliminates out. And I have a negative 8y plus a negative 1z is equal to, let's see, that's going to give me a 6, a negative 51. And so I'll circle that. And then I will put these two equations together. And if I've done it correctly, we'll be able to quickly find another variable. Let me rewrite them here. All right, so we want to multiply this bottom one by perhaps -4 so that we make this a +4. So we won't have to do anything to the top one. So 5y plus -4z is equal to -56. Multiply this one over. So that's going to give me a +32y plus a +4z is equal to a +204. I believe is correct on that one. So I'm going to add these. They eliminate out. When I add this one, I get a +27y is equal to, and I'm going to take 204 minus 56. So that's going to give me a 19, that'll be a 14, that'll be an 8. And so that's going to give me a 148, and it's going to be positive. So I'm going to take that and divide it by 27. And that should go in there, let's see, I think about 6 times. 6 times 7 is 42. Oh, that's going to be too high. Okay, so we'll have to back that off. And that may be, let's see, a 5. And that's not going to come out even. So we're going to back up. Somewhere along the line we have made a careless mistake. Or maybe I wrote the problem wrong. It's right here. This is 135. Okay, so that's going to give me 135. That's going to be a 6. That's going to be a 41. So if I change this to 41, then when I multiply here, that's going to give me a 164. Okay, 4. Okay, so that's going to be a negative. No, it's going to be a positive 164. So then I'm going to come back over here. I'm going to borrow. That's going to be an 8. And that's going to be 15. So it's going to be a 0. So I have 108. So I'm going to divide that by 27. It's very important to keep from those careless mistakes, as you just saw. So 28 is going to be give me a 10. So that's going to come out even right there with a 4. So I know very quickly that y is equal to 4. So that's one thing that I have tried to solve for. Now I'm going to have to go back and find x and z. And I can go back in either one of these equations to solve for the z. So I'm going to plug in here. So I have a -8 times a 4 plus a -z equals -41. So that's going to give me a -32 plus a -z equals a -41. I'm going to add the 32 to both sides, and I'm going to get a -z equals a -9, or z equals 9. So now I've got the z. And now I have to go back to one of my original equations and plug in. So let's do 4 times x, I still don't know what x is, plus 3 times y, which is 4, plus 2 times z, which is 9, equals 34. Okay, so that equation came from right here. That was one of the original equations. So I have 4x plus 12 plus 18 equals 34. I have 4x plus 30 equals 34. So I have 4x is equal to 4, or x is equal to 1. So those are your solutions, 1, 4, and 9. Those would be, but if you plug these back in, they would all work. That would be where they would intersect if it was graphed three-dimensionally. Okay, your homework is on page 176 through 178, 12 through 34 through 38 even, not 36.